In the fine to coarse interpolation, you're introducing what's called the aliasing error. And I'm going to use an example here. Okay. So that the example here, that's related to the high frequency content and low frequency content. So let's imagine a low frequency content that is corresponding to the second eigenvector of the matrix we just constructed, and this has an n equal to 19. So it's a low frequency content in the sense that when we interpolate the solution from the fine grid to the coarse grid, or let's imagine this is actually the residual. So when we interpolate the residual from the fine grid to the coarse grid, we are still having a very good representation of the same residual. But imagine if we have a very high frequency content that corresponds to like the second largest eigenvector of the matrix. We get a solution like very oscillatory like this. What happens is when you pick every 2 points, like only the blue points, that's the every 2 points, you get a solution, you get a residual like this, which doesn't look like the original solution, the residual on the fine grid at all. That's what's called the aliasing. It's the aliasing. I think if you go online and search for aliasing, the biggest source of examples are from computer graphics, where you have a texture that is very fine and you put it very far away and render the texture using some pixelized basically on the image. You're gonna see patterns that looks completely fake, and that is because when you are sampling at a much lower rate than the rate you need to resolve that function, you pick up low frequency contents that are not there. Okay, that's the patterns you see when you look at an image rendered without this anti-aliasing effect turned on, and you're going to see patterns. You're going to see low frequency contents that shouldn't be there. Maybe for those who haven't seen it, it's better for me to actually open Google aliasing. Yeah, you see things like, let me see if I have good examples. Yeah, I think this is a pretty good example here. So without anti-aliasing, you see these kind of ring patterns that aren't there, right? You see these kind of patterns that they are low frequency in the sense of like the appearance, but they are actually an aliasing of the high frequency content. So these are just looks weird in a computer graphics context, but they introduce error in the multigrid context. Because when you solve the error equation with this kind of aliased residual, and when you add the solution of the error equation to the solution after pre-smoothing, instead of reducing the error, you may actually increase the error because you are adding components that shouldn't be there. And this is one of the top causes of multigrid not working, is the pre-smoothing not doing a sufficient job of reducing the high frequency content. Okay, so if you're debugging your multigrid and it doesn't seems to be converged, check the solution after the check the residual after the pre-smoothing steps to make sure you are not incurring aliasing error. Okay, another thing is interpolation error. Is when we interpolate the coarse grid error solution to the error equation onto the fine grid. We were just doing, for example, linear interpolation, right? So we are we ended up with this kind of straight lines between these every two grid points. And the difference between the difference between our piecewise linear interpolation and let's say an extremely good interpolation is an error that looks like this. Is this a high frequency error or low frequency error? It's a high frequency error, and that is exactly why we want these post-smoothing steps. I mean, the post-smoothing are very good at reducing this kind of interpolation error. The post-smoothing is not strictly necessary for multigrid to converge, because if you think of every two cycles of multigrid, it's like the pre-smoothing and post-smoothing are exactly before and after each other. But the post-smoothing is very good at reducing the high frequency error as a result of the interpolation. So that's why it is there. Okay, any questions on multigrid? This is like all we are going to discuss on multigrid, which is going to be the primary focus of your project 2.